Camera friend.
All right. So we're going to focus on angle pairs today. And by the end of today, I want you to be able to name 4 different angle pair relationships. But I bet, if you think about this, you can already name 2. So what does angle pair mean? An angle pair is just 2 angles. So do we already know the name? Yeah. If we have 2 angles that add up to 90 degrees, we call those complementary. Now, typically, what's going to happen with complementary angles is that they will actually form a 90-degree angle. Right? So this would usually look like this. So I have angle 1 and angle 2. These 2 angles are complementary. And then you guys said supplementary. I think typically what's more common in geometry is you'll hear a linear pair. And as far as I can tell, that just means the same thing as supplementary. I'm not 100% sure on that. But these are 2 angles that add up to 100. So if I have angle A and angle B, these 2 are a linear pair. They form a line together. So for example with this, if I told you that angle B was 75 degrees, what is angle A? The measure of angle A. 105 degrees, exactly. Right. So by looking at one angle, I can determine what the other one is, because I know that they have to add up to one. And this is really why these relationships are important, is because once you start to get into more advanced geometry, you're going to be figuring out what different angles are based on the angles around them. So the next type of angle pair is called adjacent angles.
I know what that is.
What do you think an adjacent angle is?
When they're like adjacent to it, with like diagonal from each other, they are the same thing.
No.
Isn't that it? When they
That's the last one. Adjacent angles are just next to each other. Yeah. They share a vertex on the side. So if I had something like this, angle A and angle B are adjacent angles. There's not really anything that we can tell about adjacent angles, just by the fact that they're adjacent. But in certain situations, adjacent angles can tell us something about one angle or the other. Then the last one. This is probably the most important, I would say. Are called vertical angles.
I know what that is.
Yes, and this is what you were saying earlier. So these are angles. What did you say earlier, Mira?
Like when they're diagonal from each other or whatever.
Yeah, I like how you put
Probably
that.
the same thing.
And I want to spend a little time on this one. Two angles that are diagonal from each other. So if I have two lines like this, A and B will be adjacent angles.
Wait, what? They're not adjacent.
I mean, sorry, vertical angle. Right. I said them up. Yeah.
So A and B are the same.
So so there's a really important thing called the vertical angle theorem, which we'll look at later in terms of how we actually prove this. But there's something that we know about vertical angles, which is that a set of vertical angles is always equal. A would be equal to B. I want you to just look at that diagram for a second and try to think about why that might make sense. We're not going to do an actual proof of this today. I haven't taught you how to do proofs yet. But we can still reason it through. We can think about, well, why would this have to be equal to this? And what might help is if we also label these C and D. Yeah.
Well, since they're continuous lines, they're kind of like mirrors to each other.
Okay. Yeah, so they're on like a continuous line, right? And that makes them mirror images in a way. Anyone else have a thought about why they might be equal? I like the way you thought of it. Another way that I kind of think about it is if we started with a perfect plus sign, right? So these are all 90 degrees. Then I know A and B would both have to be 90, right? And as I adjust this middle line, so if I move it this way, A is going to get smaller by the same amount that B is going to get smaller. Because I'm just moving this one line and I'm rotating it along this vertex. So they would always have to stay the same, right? Or if I moved it the other way, A would get bigger by the same. So it's just kind of another way of thinking about why these are equal. What angles in this diagram, what angle pairs can you identify? Let's try to. Lila.
A and D are supplementary angles.
Yeah, they're a linear pair. Good.
Sorry,
And okay, and D. So we've got A, D, linear pair. Mira.
C and D are adjacent angles, so we're A and C and D and D and A and D.
Yeah, C and B are adjacent. Yeah, and so are Uh-huh. What's two angles that add up to 180 degrees called? A linear pair.
360.
Yeah.
C and D are vertical angles.
C and D are vertical angles.
Is there a complementary angle?
Yeah, in this diagram there are no complementary angles, right? We don't have a 90-degree angle anymore. Yeah.
C and B are a linear pair.
C and B. Yeah, in fact, all of these
Are linear.
are adjacent and linear pairs, right? You guys had already said some of the other ones. So each adjacent angle here is a linear pair because they're all on lines. There's one more set of vertical angles which we already talked about, which is
A and B.
A and B. There's no examples of complementary angles in that diagram because there's no 90-degree angles. All right. Questions?